Hello, my name's Gabriel, and I'll be talking to you about demand sensing for sales forecasting, a project that I did with a consumer business unit of faculty. Introducing this subject, I want you to imagine yourself as an ice cream merchant. And if you were to go about traditional sales forecasting, you'd ask yourself, how much do I sell normally? And how much do I sell at this time of year? But if you look outside the window and you see that there's a storm on the horizon, it's not going to be a good day for sales. Conversely, if it looks like this outside, you know it's going to be a bright day for sales. What I'm getting at is that external features are drivers of demand. Things like the weather, but also sporting events, temperature, competition, CPI, marketing, and the news. And while a human can do pretty well at forecasting for a single store, you need machine learning if you want to do this for a whole retail operation. That introduces our first question. Will including external features in a machine learning model improve sales forecasting? And to address this, we went to readily available data that's online from a major American retailer. In it, we find 45 stores with 64 to 81 departments each, and we've got weekly sales data for more than 156 weeks. Moreover, we've got external features, so unemployment, CPI, temperature, fuel price, and 5 anonymized marketing campaigns that relate to every single week for every single store. Starting out then, we create a forecasting baseline. So on the basis of the mean sales of every department in every store, we can simply calculate what would be the mean sales minus the true sales and divide it by the true sales. And if we do this whole thing log transformed, you get a very nice looking Gaussian that tells you that around 0, you have basically 0 error. So the mean is the same as the true sale. If you go negative, then you're undershooting. If you go positive, overshooting. That leads us on to our random forest machine learning model using traditional forecasting. So now we introduce the features of store size, but also week number and holiday. And all of these are intrinsic either to the store itself, like for store size, or to the year, like the weeks and holidays. And we take the predicted sales minus the true sales and divide by the true sales. And we see a 24.2% improvement upon the baseline. And you can see this visually because the Gaussian is narrowing towards 0, a perfect fit. Next, we look at feature-enhanced forecasting. And by that, I mean the external features: unemployment, CPI, temperature, fuel price, and marketing. When we do that, we get a further 5.1% improvement, which you can see by further narrowing of the Gaussian. Leading then to our next question: can natural hierarchies in the data further improve our model? By natural hierarchies, I'm referring to the fact that these 45 stores map onto 3 types: convenience stores, supermarkets, and mega markets. And if you take the feature-enhanced forecasting model using the random forest, and we apply it, but only now to convenience stores, and separately also for the supermarkets and mega markets, then we can get a further improvement of 1.2%. But the real value of this type of hierarchy is that you get actionable insight. In this case, which features are the most important. And here, what I'd like to highlight is the fuel price, first of all, which seems much more important for a consumer store or convenience store. By contrast, there's a marketing event that seems really important for supermarkets and mega markets. And that, by cross-checking a few dates, we can figure out is Black Friday. And that makes a lot of sense. To summarize then, we've got that including external features in our machine learning model improves sales forecasting. Incorporating the natural hierarchical structure of the data in a machine learning model improves sales forecasting and, crucially, interpretability. And then next steps. So at faculty, we want to be at the cutting edge of demand sensing. We want to move beyond this traditional mantra onto product by product demand sensing on an hourly or at least daily basis. And we want to have a final readout of demand, which not only includes sales, but also tracks orders and out of stock events, as well as product cannibalization. And the reason why that is so important is because change, especially the hourly or daily change, is a major driver of human behavior. To exemplify, in the example of ice cream, when it's a stormy day, you're not selling ice cream, and when it's a sunny day, you will. That's true, but at the same time, Norway has the highest ice cream consumption per capita. As a Norwegian, I can tell you Norwegians go crazy the moment there's a little ray of sunshine. We run out and we binge on ice cream. That illustrates the importance of change. Finally, I'll leave you with a message. The best-in-class retailers use demand sensing to boost sales and improve supply chain management. Thank you for your time.